are you all doing? Sorry for 2 minutes late. I'm really sorry. How are you all? Good morning, Chahat Kumari. How are you? Hello everyone. Hello everyone. Mark your present by saying hi. Hi everyone. How are you all doing? How is your preparation going? The exams are like really near now. Good morning everyone. Today we are going to look at another sample paper, and today's sample paper, as some of you commented on the shorts, on the videos, today's sample paper will be a mixture of what? KV plus Sahodya. I actually don't know the spelling of Sahodya, so sorry for that, but it will be a mix of the pre-board that came into Sahodya as well as KV, right? Hi Ramesh. Okay Ramesh, you remember my age, that is good. Hi Shivani Pandey, how are you? Yes Ramesh, I do remember you. How are you all doing? How is your preparation going for your math exam, right? So on 17th Feb you have maths exam. How is your preparation going? Hi Pratibha Yadav. Hi everyone. Okay, so can we start this live? Everyone give me a thumbs up if we can start this live. We will be seeing all the questions. So I mixed the paper of KV and Sahodya. Okay, so we will do from MCQs, assertion, reason question, numericals, and ray diagrams, circuit diagrams, everything in this. Okay. Hi Prem. Okay, let us start this live session. Let us move to our very first question, that is excellent, great. Okay, let's move on to the very first question. That is a very simple, very basic question. You guys have to give me the answer of this question really quick. Okay, we have a prism and we can see that a white light is passing from it. It is written that it is a prism, and we have XYZ lights, XYZ rays. Yes, I got your thumbs up. I got your excellent, good morning, very good. Now give me the answer to this very first question. Okay, the image shows the dispersion of the white light in the prism. Okay, what will be the sequence of colors dispersed in the form of X, Y and Z? What is the color dispersed in the sequence in the form X, Y, Z? Will it be red, green and violet, violet, green, red, green, violet, red, red, violet, green? Let me know. You are saying X is red, okay, Y is green and Z is violet, okay. May I ask you to think again, everyone? Shivani, Chahat, Ramesh. Are you guys again sitting together? Let me know. Think about it. Think about it. Everyone, Chahat, Ramesh. Okay, everyone. I am a little bit surprised, to be honest. Okay, let us see. Now, be very careful. Be very careful while doing these questions. See, you have a prism, right? You have a prism. Do I have a triangle? I have a triangle. See, this is a prism, right? Now, while you are attempting, while a ray is incident on it, what happened? A refraction and dispersion happens, right? And on the second base, on the, Shivani is saying B is the second answer. This is the second answer, violet, green, red. Okay, let us see. So from the second path also we get dispersion as well as refraction. Now a very important point, everyone, Shivani is only saying B and Shivani is right. Very good, Shivani Pandey. B is actually the right answer because we know that a pattern forms, that is VIBGYOR, right? VIBGYOR forms, but in the inverted sequence, in the down we have violet, then indigo, blue, green, yellow, orange and red. So in the last we have violet. What is the last one? X is the last one. So X will be what? X will be violet. Y will be again green. And the upper one, Z will be red. What happened, everyone? Prabheet, Jack is also saying B. Yes, Chahat, B is the right answer. Very good. Now clear, everyone? Anyone has any doubt? So B is actually the right answer. Correct answer is B. Done? Any doubt in this? Now why I got this question for you? Ramesh, did you see we made this prism? I have this prism, right? This is the prism angle and all. When the ray falls on the first surface, it gets refracted and dispersed. So when the ray comes out, it forms a pattern VIBGYOR and it is in the inverted sequence. We have studied about it. VIBGYOR is the pattern. Okay. Done. This is correct. This is the correct answer. Okay? Done? Okay. So B is the correct answer. Same, this question has been repeated in both the papers, KV as well as Sahodaya. In both pre-boards this question was there and in lots of PYQs this question was there as well. So now I know why, because you all are getting confused. I thought this is very simple question, but it's fine. Now you know, right? Everyone understood? Give me a thumbs up. Yes, very good, very good. Okay, this is the same. Okay, now give me the answer for this. In the following diagram showing dispersion of white light by a glass prism, the colors P. This is P. The lower one, it is P, and the upper one, it is Q. Okay, now respectively P and Q respectively are what? A white light getting dispersed, coming out. P is what and Q is what? Jai Hind Sharma ji, how are you? Welcome back to the live session. Give me the answer to this question. A lot of you gave the wrong answer for the last question, but now you understand. Now is it fine? Hi Muthul, Lakshmi Muttu. Hi Lakshmi, how are you? Okay, D, we have one answer as C. Okay, we have answers as D or C. Anyone else with A and B? D and C, D and C. Okay. Jack is saying D. Shivani is saying A. Okay, we have A answer as well. Anyone else who wants to say B? Shivani is saying A, Chahat C, Jack D. Okay, let us see. Nothing, you don't have to do anything new. The same diagram we saw the last time. See, the last one, we have two rays to cover this pattern, right? The last one will be violet. This was P. In the next question, in this question, the lower one is P, right? So this is P and this is Q. So the lower one will be violet. So P will be violet and Q will be red. P will be violet and Q will be red. Now P and Q. So first you have to tell about the P and then you have to tell about Q, right? First P and Q respectively they have asked, right? So the first color that is given will be P of P and the second will be of Q, right? C, D, P will be violet. Very good, Sharma ji. So P is actually violet, right? And Q will be of red. P is at the bottom. What is at the bottom? At the bottom we have violet. What is at the top? Q. What is Q? Red, right? So P will be violet, Q will be red. That means A is the correct answer. Okay, very good everyone. Whoever said A, very good, very good. Done? Yes, answer is A, everyone. Understood, Chahat? Oh, Jack is saying A, B, C, D. Okay. Anyone has any doubt in these two questions? This is a very repeated question. Yes, yes, Jack, I understood. This is a very repeated question. As you can see, this has come both in pre-boards of Sahodaya as well as KV. Okay? Okay, great. We have got the thumbs up. Let's move on to the next question. Very, very important. A bit of a different question from the previous we have done, but same concept. You don't need to think about it in any other way. Same concept. Just use your brain a little bit. Okay? Okay. B1, B2, B3. B1, B2 and B3 are three identical bulbs as shown in the figure. When all the three bulbs glow, all three bulbs are glowing, then what is happening? A current of 3 ampere, the reading of ammeter, a current of 3 ampere is recorded by ammeter A, right? What happens to the glow of two bulbs when the bulb B1 gets fused? First, let me know what is the meaning of bulb gets fused. Hi Sudarshan, how are you? Seen you after a lot of time. Okay, hearts and fire from Sharma ji. Okay, great, great. C, everyone is saying C. Oh, you guys are really smart. You do know the answer. Sharma ji is saying, Ramesh and Sharma ji are saying C. Yes, 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 I saw. Chahat is also saying C. What is the reason? The reason I'm asking. What is the reason and what is the meaning of B1 getting diffused? What is the reason for your answer as C? I want reasons. Okay, from now on, every time you are giving some answer, you have to give the reason with it as well. Okay? Parallel mein hai, that's why no change. Very good. Okay, great. Yes, yes, very good, Sharma ji. Great. So, what is happening? In the first case, the circuit is complete. How you have to write? Watch it very carefully. Okay, this is MCQ, so you don't really have to write. But you guys are correct. The correct option is option number C. Glow of the remaining bulbs won't change. But if you get it in more than 2-3 marks, right? They can give you this as a numerical. Correct? Do you know how to write this? No change in parallel. Yes, very good, Chahat. Series, yes. Series hota. Great. Yes, Sharma ji, very good. B, Raghav is saying B. Okay? Okay. If this question came in as numerical, how do you have to write? First, this is your circuit, right? So, your voltage is 4.5 volt. Your voltage is given as 4.5 volt, right? And the current reading is 3 ampere, correct? From here we have 3 resistances and they are in parallel and they have same reading, same resistance, right? They have same resistance. So I know that current divides in parallel. I know that current divides in parallel, right? It divides in parallel. So in each resistor, as the resistance is same, as R is same, so in each resistor same current will flow, right? Same current will flow in each resistance, in each resistor. And in parallel current divides, so it divides equally. That means in R1 we have 1 ampere, in R2 we have current as 1 ampere, in R3 we have current as 1 ampere. Clear everyone? Yes, yes, Sharma ji, ask away. 3 identical bulbs are connected in parallel across the voltage source. In parallel circuit, the voltage across each branch is same. Yes. When bulb B1 gets diffused, its branches become open and no current flows through it. However, this does not affect the voltage across the parallel branches. Very good everyone. Very good. Hi Harsh, how are you doing? Okay, done. So in each circuit we have equal current flowing. Done. Now if B1 gets diffused, if B1 gets fused, voltage won't change, right? Voltage won't change because it's a parallel connection. And that's why current will also won't change, and hence current will also not change. Done. And hence they will glow with the same brightness. Very good, everyone. Whoever said that the brightness remains, the glow of the remaining bulbs remains unchanged, very good. Arey, Harsh, that is not good. Okay. Jack, this session just started at 11. We will be seeing 15-16 questions of the whole sample paper, including assertion reason, MCQs, long answers, numericals, everything. Okay? Okay. Next we have a question for you guys. Before that, there is a link in the description. Go join that WhatsApp channel. Today I will be sharing the PDF of this solved sample paper in there. Done? Several electric bulbs are used to design 220 electric supply line rated 10 watt. How many lamps? I think I have this question in this sample paper. Can you just wait for a few minutes, Sharma ji? I think I have the same question in this whole slide. Okay? If not, I'll solve that. Yes, Raghav, answer is C. Very good. Okay. Hi, Tanmay. Okay, moving on to the next question. One end of a wire carrying current in the downward direction is placed in a trough containing mercury. Here you have mercury, right? So that the direction of force experienced by it is clearly visible. Two poles pieces, north and south, are placed on each side as shown in the diagram so as to provide uniform magnetic field. What is the direction of force experienced by the wire? Away from the observer, constant position, upward from the observer, towards the observer. Now first all of you let me know which is the rule that we use to find the direction of force. Which is the rule that we use to find the direction of force experienced by a current carrying conductor placed in a magnetic field? Towards the observer, Ramesh is saying the answer is D. Jack is also saying D, towards the observer. Which rule did you use, guys? I'm asking you a question. Which rule did you use? We are here not just to see the answer but to understand the answer as well. We use Fleming left hand rule. Very good, Sharma ji. Very good, Ramesh. Great. Fleming left hand rule. Great. Correct. So this is my left hand. Fleming left hand rule says that if you point your index finger in the direction of magnetic field, middle finger in the direction of current, and thumb will give the direction of force, and they are mutually perpendicular to each other, right? So we can clearly see that the current is in downward direction. So my index finger is in downward direction. The magnetic line will go from north to south. That means in this direction. So my middle finger is in this direction and my index finger will be in that downward direction, right? This will be it. This will be, right? Current in the downward direction, magnetic field from north to south, and thumb gives the direction of force, that is outwards or towards the observer. Very good. D is the correct answer. Everyone, very good. You guys are really smart. What happened, Harsh? Why are you so angry? Thumb points in the direction of force. Very good, Ramesh. Very good. Outwards, towards the observer, or out of the plane. Very good, Sharma ji. Why the resistance is same? It is given that the resistance is same, Raghav. It is given. See, three identical bulbs They have written, right? So if the bulbs are identical, their resistance will be same. Okay? Okay. Let's move on to the next question. We have one assertion reason question for you guys. Let me know the answer to this question. Assertion says light does not travel in the same direction in all media. Reason says the speed of light does not change as it enters from one transparent media to another. Okay, Harsh. Just focus on the questions, okay? It's fine. It's directed by the observer. Very good, Ramesh. Thumb force, father, forefinger, magnetic field, mother, middle finger, middle current. Middle finger gives the current. Yes, child. Very good. Jack has given us the trick to remember, that is father, mother and child, where father is force, mother is magnetic field and child will be current. Very good. Okay, everyone is giving the answer as C. Sharma ji, Ramesh, Shivani. Okay, Jack, all of you are giving the answer C. Okay, let us see. So, light does not travel in the same direction in all media. That is true. We know that light does not actually travel in the same direction. When it goes from rarer to denser or denser to medium, it bends towards or away from the normal respectively. So, assertion is actually true. The speed of the light does not change as it enters from one transparent medium to another. That is, my friend, not true, because we know a very important formula. See, do you all remember the formula I told you? You all remember the formula I told you for refraction? Yes, Sharma ji, I know you are scared from refraction. Look, just remember this formula. N1 divided by N2 equals to V2 divided by V1 equals to lambda 2 divided by lambda 1. That is my wavelength, right? Correct? And which was equal to sine I divided by sine R. Right? So, we know when light goes from one medium to another has different refractive index. That means its velocity will change. So, reason is not true. That means A is true, C is false. C is the correct answer. Very good, everyone. Assertion is true. Light changes direction when it passes from one medium to another, and the phenomena is called refraction. Very good, Ramesh. Jack is saying C. Very good, very good, very good. Ma'am, dangerous. It's fine, Sharma ji. I know it is dangerous, but it will be okay, okay? Are Harsh, why are you saying it's fine to get scared? Okay. Saravanan is also saying C. Very good, Saravanan. Let me know your name, okay? Please explain the assertion. Okay, assertion says light does not travel in the same direction in all media. Right, Shivani? Is that true? Now, we know when light, this is my medium and this is air and this is water. Right? So, if light is coming something like this, we know when it goes into the air, it will bend towards the normal. It should go like this, but it bends towards the normal. Right? That means the direction changes. The direction of light changes. Correct? And that is why, my friend, it is not true. It is true, light does not travel in the same direction in all media. Light travels in different direction. Okay? This is, Sharma ji, the sample paper we did last time, right? This is a pre-board sample paper, a pre-board paper of Kendriya Vidyalaya as well as Sahodaya, right? So this is a pre-board paper. And I combined all the questions that looked scary to me. Okay? Okay, Shivani. Great. Okay, Kirti. Welcome to the class. Okay, done. Next we have again one more assertion reason questions. Let me know the answer. The mirrors used in searchlights are concave spherical. Reason says in concave spherical mirror the image formed is always virtual. What is the correct reason? What is the correct answer for this? Let me know. It's fine, Sharma ji, it's fine. Solo edits. Arey, what happened, solo edits? Why are you in the hospital? What happened? Shivani is saying C. Jack is also saying C. Okay, you guys are saying that A is true but R is false. Okay, then let me know if R is false, then what is the reason? What is the exact correct reason? What is not true in R? Let me know. Ramesh, Kirti, Harsh. Okay, everyone, Shreya, all of you, because only in one case the image is virtual. Okay, very good, Shivani, great. Yes, the mirror used in searchlights are concave spherical, that is true. Okay, so we know that in searchlights we do use the mirrors that are concave. Concave mirrors are used in searchlights, so assertion is true. Very good. Now in concave spherical mirror the image formed is always virtual, as Shivani said. Yes, as Shivani said very correctly, that in concave mirrors only one case we have, that is sixth case, where the image is virtual. In all cases, in first to 5 cases, the image is real and inverted. So reason is false. C is the correct answer. C is the correct answer. Very good, everyone. Only one case is virtual. Yes, it should be real and inverted. Correct, Sharma ji. Okay. Great. Can be virtual or real or inverted. Yes, very good. Done. Okay, let's move on to the next. We have another assertion reason question that says 2-bar magnets attract when they are brought near to each other with the same pole. Read it very carefully. With the same pole, and reason is unlike poles will attract each other. Unlike poles will attract each other. Hi Sona, how are you? How is your preparation going? Hi Kirti, my name is Aditi. I am Diamond. Oh wow, Harsh, that is some great humor you have. Okay, Kirti is saying D, Shivani is also saying D, Ramesh G is saying reason is false because a concave spherical mirror can form both. Yes, very good Ramesh G, very good. And Jack is also saying D, Shivani is saying opposite poles attract each other, not same poles. Yes, correct. Like poles repel, unlike poles attract. Hi Madhav. Okay. Everyone is saying D, and D is the correct answer. All of you are doing great. It feels like I don't even have to explain anything. All of you are giving great answers. So we know 2-bar magnets attract when opposite poles like north and south are brought together, then only they will attract, not the same pole. So this is wrong. And reason says unlike poles will attract each other. That is true. Unlike poles will attract each other. So D is the correct answer. Very good. Next, next we have now a numerical. Let me know. Get your pen and paper. I'll wait for 10 seconds because at this point you should have pen and paper with you. Okay? Done. Next, we have a spherical mirror produces an image of magnification -1. Okay. Yes, we almost, not for physics I don't come daily, but in a week I come 2-3 times, okay, for physics. And we have another classes as well, math, SST, chemistry. Okay, magnetic field lines flow from north to south pole. When north pole is brought near a south pole, the field lines connect, causing an attractive force. Oh, nice, Jack. Okay, everyone get your pen and paper. First rule, Sharma ji, wait. First rule is we write as we read the numerical. We write as we read. So, a spherical mirror produces an image of magnification -1. So, we will write that magnification is -1. On a screen placed at a distance of 50 centimeter from the mirror. So, V is 50 centimeter. We will decide the sign later. Okay, we will decide the sign later. First, we are just writing. We have to find the distance of image from the object. We have to find the distance of image from object, right? And B, we have to find what is the focal length of the mirror. Okay, let me know the answer, everyone. Oh, this came in your MCQs. Great, Sharma ji. And the answer to the second part? -25. Why minus, Sharma ji? Okay, till Sharma ji gives the answer, we'll solve the question. Okay, everyone, see very carefully. Done? So, the first thing we have to look in this kind of questions is the sign. First, see, magnification is -1. So, what can we derive from this? Everyone, what can we derive from this? What is the nature of image when magnification is -1? Let me know. Image and object is both at center of curvature. C. See, what is C, Raghav? 0, -25, -25. Very good. Now, let me know. What is the nature of image when magnification is -1? It is real, right? And inverted and of same size. Very important. It is of same size. Now, if it is real and it is inverted, that means in itself we are using concave mirror, because convex mirror never produces real and inverted image. And if it is of same size, that means the object is at center of curvature. The object is at the object is at center of curvature. Done? So is the image. The image is also at center of curvature. Everyone, real and inverted, very good. Case 3, Sharma ji is saying U is placed at C. Very good. So U is placed at C. Image will also be at C. Because it is real inverted, it is on the, it will be formed on the same side, right? Something like this. This is F. So something like this. So this is my image forming, right? So U and V are same. That means the image and object are both at center of curvature. So distance between V and U will be 0. Distance between V and U will be 0. Very good, everyone. Now, if center of curvature or radius of curvature is what? 50 centimeter, right? And it is for concave mirror. Remember, everyone, it is for concave mirror. It is for concave mirror, right? For that we have sign as negative. So focal length will be simply radius of curvature by 2 minus 50 divided by 2, that is 25. So focal length will be minus 25 centimeter. Very good, everyone. Ma'am, case 3 and 6 are important. Yes, Sharma ji, very important. Those are very important. Perfect. The focal length of the mirror will be minus 25. Very good, Ramesh ji. Hi, Raghav is saying, how are you? Who are you asking to, Raghav? I am great if you are asking me. Hello, friends. Hello, Surender. How are you? Okay, next numerical we have a very okay-ish, great numerical. Let us see. An object 5 centimeter in length. As we read, we write. So height of object is given as 5 centimeter. Is placed at 25 centimeter from a convex lens. We are given with convex lens, and U is 25 centimeter, but U is always negative. So that means u is minus 25 centimeter. Done. Of focal length 10 centimeter. Focal length. Everyone, let me know what is the sign of focal length of a convex lens. What is the sign of focal length of convex lens? Yes, Madhav, every day the class, we come live every day, and from tomorrow we will be starting from today. In the evening we have a math, live for math, and from tomorrow on we have a chemistry live, and from day after tomorrow we will be having math lives. Okay, the focal length, ma'am, but if we will use mirror formula, then my answer is 0. In which case, Shivani, how do you use mirror formula? No, see, in this both will be negative. We will be negative and you will also be minus 50 centimeter. Take the signs very carefully. Now solve it. Now let me know what is your focal length. If both signs are negative, let me know what is your focal length. Everyone is saying positive. Very good, very good. For convex lens as well as convex mirror, the sign of focal length will be positive. So be positive. Always be like convex lens. Okay, so focal length will be positive. Great. Now we have to use the lens formula to calculate the image distance. We have to find V. Can you guys solve this using lens formula? 16.6 centimeter. Math live will be today evening 5 p.m. I'm thinking. Go join the WhatsApp channel. There is a link in the description, Madhav. You will get every information in that WhatsApp channel. Okay, done. The distance is 0 centimeter of image and object. Yes, Raghav, very good. Arav is saying positive. Yes, Shivani. Be very careful while you are taking negative sign of V. Okay? Okay. Find the size of the image using magnification. Okay, we have to find first V and then magnification, mostly its sign, right? State the nature of the image and we have to tell the nature of image. This is we have to find, right? This all is given to us. Correct? Let's do the solution. Okay, Shivani, great. Okay, let us do the solution. What does lens formula say, everyone? Lens formula says that do not forget to take a negative sign. 1 by V minus 1 by U. Lens formula says that I am negative. Okay. Hi, Priyanshi. Today's math live, go join the link in the description for the WhatsApp channel. There you will get every information. Okay, now U is minus 25, F is plus 10. F is plus 10, U is minus 25. So minus of minus 1 by 25, right? So if we have to calculate V, that will be 1 by 10 and this is plus 1 by 25. So 1 by V will be 1 by 10 minus 1 by 25, right? Can we simply just take 250 as LCM, okay? So this will be 25 minus 10. So 1 by V will be what? It will be 15 divided by 250 and then V will be 250 divided by 15. Now can you solve this calculation, everyone? Radhe Radhe Yadav ji. 3.3 ही आया है. What? Magnification. Sharma ji? The image distance will be, where are you copying your answers, Ramesh? I can't even see. 16.67 centimeters. Let me get my chai, everyone. We are chai pagloos, as Sharma ji says. Okay. Okay, Priyanshi Mishra. Welcome to the chat, Mishra ji. 50 भी ले सकते थे. For what, Sharma ji? 15, 15, 15. Okay, height of image is 3.3. Size of the image using magnification. Okay, let us see. Now V comes out to be what? V comes out to be, if we cut this will be 1, and see, do this division very carefully. If you have to do it like this, it doesn't matter. Okay, so everyone is saying 16.67. I'll just take your words. Okay, I hope you did the calculation by yourself. Sunita, hi Sunita. This is for CBSE mostly, Arav. Yes, Sharmaji, Chai Paglu is active. Okay, yes, great. Priyanshi, everyone. Bhargav is also saying 16.66. Very good. Great, till here clear. Now we are done with the first part. We calculated V. Now we have to calculate size of image. We have to calculate size of image, right? So can we use a formula of magnification, right? Magnification is, we have V by U for lenses, positive V by U, and this is height of image divided by height of object. Now this is 16.67 divided by U is what? U was 25. U was 25 but of negative, right? U was negative 25. Great. And we have height of image, we have to find. Height of object was 5 centimeter. Height of image divided by height of object. So height of image comes out to be, this is 5. So 16.67 into 5 divided by 25 minus, this is 5, and this will be 3.33. Yes, so height of image will be minus 3.3, everyone. Nobody wrote minus. It is minus, right? Image is real and inverted, but what was the sign of the image? Sharma ji, Ramesh, Kamal Das, how are you? Minus 3.3, yes, Shivani. Yes, minus 3.3. Very good, everyone. Great. Done. So height of image is minus 3.3. Next part we had to find the nature. Now if height is minus, that means it is below the principal axis. That means it is real and inverted. From there we can also know that it is a convex lens. In case of convex lens, see, in case of convex lens, right, here we have focal length, object distance is greater than focal length. That means it is not the exceptional case. That means the image will be real and inverted. You don't even have to solve for this part, right? Great. Object is beyond 2f1. Yes, object is beyond 2f1. Very good. Yes, Priyanshi, I'm guessing. Okay, yes, negative tha Sharma ji. Great. Everyone, let's move on to the next question. Done with this part. Easy, but see, listen to me very carefully. All of you know how to solve the question. All of you know how to even write the question. But all of us are making silly mistakes here, right? All of us can see we forgot to put negative sign, we forgot the Vibgyor pattern, right? We forgot to take negative sign in V, that's why focal length came as 0. So I'm not targeting anyone, it is very normal, but make sure you do not do any of these silly mistakes. Okay? Hi Sahil, hi Lavish, how are you? Done, everyone? We are here to improve on our silly mistakes. Make sure you give extra attention to negative signs, to formulas, to calculations. Okay? Okay. Let's move on to the next question. We have a potential difference of 220 volt. This is a very easy question and it came in pre-boards. So see, a potential difference of 220 volt a potential difference of 220 volt is applied across a resistance of 440 ohm. So resistance is 440 ohm. Then in an electric appliances, we have to find the current. This is easy. I won't do this. And the heat energy, that I'll do. Let me know the value of current. Everyone, simple use V equals to IR. Om Baba ki jai. Right? Simply use V equals to IR. Half ampere, Sharma ji is saying the current will be 0.5 ampere. Great, Lavish. How is your preparation going for the boards? Okay, great. Simply use V equals to IR. V is what? 220. I we have to find. R is 440. I will be 220 divided by 440. So I is 1 by 2 ampere. That is 0.5 ampere. And now we have to find heat. Right? We have to find heat energy produced in 30 seconds. Done? We have to find heat energy produced in 30 seconds. Correct. So what will we do? Simply we are going to use C. H equals to formula is, okay, let me know the formula. Let me know the formula to find heat energy. What is the formula to find? This is live, Khushi Thakur. This is live. The heat energy produced is 3300 joules. Okay, Ramesh ji is saying 3300. I am asking you all the formula. I square RT. Very good. Saravanan, can you please tell me your name again? I'm so sorry. Ma'am, this is live, Khushi. I square RT. Very good everyone. So heat energy equals to I square RT. I we found was 0.5, right? Square. R is 440. Time is given as 30 seconds. Make sure you know the time is in 30 seconds. Okay, Kirti. Okay, I'll remember now. So time is in seconds and it should be in seconds. If it is in minutes or hours, you have to convert it into seconds. Okay, and that will give us 1 by 2 square. I can write that, right, to make my calculation easy. That's how you make your calculation easy. If you do the square of this will be 0.25 and then you will have to multiply that with 44. Too much crowd. Just write 1 by 2. Okay. Hi Anju, how are you? This will be 1 by 4, 440 into 30. So this will go as 110. That will be 3300 joule. Very good everyone. Great. Man, all of you are really smart, dude. 3300 joule. Priyanshi, Shivani, Sudhanshu. Welcome back, Sudhanshu. How are you? Yes. Sharma ji, Ramesh, ma'am. Sharma ji, you can't say anything about it, but mostly it is easy. From sample paper, okay, sample paper you are asking. From pre-boards, it will be definitely easier, right? From sample paper, it will be almost of the same level, right? It will be almost of the same level. Now, let me tell you, don't forget these questions. Once those questions, see, the question came in sample paper as well. That question, the bulbs one, if one bulb closes, what happens? If one bulb fuses, what happens? How much current will pass? Power will pass? So practice those questions. I'll make sure I'll get more of those questions as well for you, right? Size 3.3, image distance 50 by 3, and the nature of real inverted. Okay, Raghav, great. Confidence, Sudhanshu, great. That is good. Legends is saying rom. Great. Okay, Kirti is also saying 3300. Very good. Let's move on. Make sure You don't forget to do these kind of questions, okay? And then questions on power as well. Done? So make sure you take out some time and sit and practice these questions, okay? Okay, next we have Nupur needs a lens of power minus 4.5 diopter, right, for correcting her vision. What kind of defect? So A, we have to tell what is the kind of defect she is suffering from. B, what is the focal length and nature of the corrective lens? What is the focal length and nature of corrective lens, right? And C, we have to make the ray diagrams. Let me know, everyone. Hi Ayushi, how are you? Myopia, Sharma ji is saying myopia. Why? Along with why? Everyone, along with why? A is myopia, B is concave lens. Yes, Sudhanshu, very good. Kirti, Sharma ji, why the defect is myopia? We are here to learn. Hypermetropia, Ramesh is saying farsightedness. The power of lens is positive, indicating a converging lens which is used to correct. Ramesh ji, wait for a minute. I guess that you are copying from somewhere. The power of the lens is clearly shown as negative, right? Negative in power, yes. Myopia, concave lens. Okay, so look carefully. The power has a negative sign, everyone. Okay, so the power has a negative sign. Power has a minus 4.5 diopter. So what do we do? The first step is to look at the sign. Sign is negative. If power sign is negative, then focal length is also negative, right? Which corrective lens? Which lens has negative focal length? Concave or convex? We have concave. Concave lens as well as mirror both has negative focal length. Now, which defect is used to correct, which concave lens is used to correct which defect? Negative sign, yes. It is defect short-sightedness. Yes. Negative sign, ma'am. Okay, let me give you some tough questions. Okay, Raghav ji, okay, done. Now, concave lens is used to correct myopia. It is used to correct myopia. So, first, the answer to first is, it is myopia, right? Second, then focal length and nature. Now, nature is concave lens, right? Focal length will be simply 1 by power, and that will be 1 by 4.5 negative. Nobody told me the focal length. Yes, minus 0.22. Sharma ji gave the right answer. Minus 0.22 meters. Remember to write the units, and if power is in diopter, the focal length will be in meters. Concave, myopia, very good. Sharma ji, Kirti, Ramesh, Horilal. Okay. Very good, everyone. Myopia, ma'am. Yes. Horilal ji, great. Minus, Sudhanshu, it will be minus. Yes, very good. You corrected. Minus 0.22 meter. Yes, Sharma ji, very good. You should not forget negative sign even in the answers, even in the given question as well, right? Okay, we have the last draw ray diagrams showing the defected eye and the correction of this defected eye, right? So how will we do that? What is the defected eye? First, in myopia, this is myopia, right? So for myopia, does the image forms in front of the retina or in front of the retina or behind the retina? First, you have to figure out that. In front of the retina or behind the retina? Let me know, first or second. In myopia, अब तो हम रेस्ट करेंगे. Okay, let me know, in case of myopia, the image forms in front of the retina or behind the retina? Sharma ji is saying in front of the retina, okay? Front of the retina. Kirti is also saying, Ramesh, it is concave. Yes, it is concave. Bhargav is saying one what? Okay, okay, this one. Very good, very good. Very good, everyone. So, we do know that this is the correct answer. In myopia, the image forms in front of the retina. So, what you have to do for defected eye? This is defected eye. For defected eye, just make an eye. This is my convex lens. Now, for myopia, the rays are coming parallel, right? The rays are coming parallel and they are meeting in front of the retina. Make sure you are using scales for this. It is meeting in front of the retina. Done. Make sure you use a scale and pencil for this diagram. Okay? This is a defected eye. What will we do to use the for corrective ray diagram, for corrective lens? What will we do? We will place a which lens in front of it? It will be a concave lens. We just studied, ma'am. Right? It will be a concave lens, correct? It will be a... This is my lens, right? Now, this will be a concave lens in front of the eye. One more concave lens in front of the eye, right? So, what will happen? What will happen? The rays that were coming from infinity, the rays that will be coming from infinity, they first meet at a far point. They first meet at a far point, right? Something like this, correct? Now, from this far point, again the rays go into my lens, into my eye lens, and the image is formed on the retina. The image is formed on the retina. Done, everyone? Now I have also used scale, kind of, okay? Oh, yes, the crown is on Hori Lal. What is this whole thing of crown? I don't get it. Done, everyone? Understood the diagram? First, in defected eye, the image was making in front of the retina, but now after we used a corrective lens, the image will be making on the retina. Okay? Diksha has schools. Diksha Vedantu combinedly, we have schools, and you can take admissions in +1, +2 if you want. Okay? I'll tell you one day all about it. Okay. Done? Crystal clear, Kirti is saying. Very good. Okay, Shivani. Okay, great. Let's move on. Now I've got you this diagram as well. So for hypermetropia, this is a normal eye, right? This is a defected eye where the image is making behind the retina, and we use a convex lens to a convex. Arey, shit. Each one of you is so bad. I used a convex lens and you are saying crystal clear. This is a pre-board paper, Raghav, of Sahodaya as well as KV. So, and we did the sample paper. So, level of exam won't be that much tough. Don't think like that, okay? Okay, Sharma ji. Yeah, that can be. Everyone, you all are saying crystal clear. I accidentally used a convex lens here. I had to use a concave lens. Oh, concave, yes. Acha, not crystal clear, but clear. So, make sure you are not doing these kind of mistakes, people. Why is it not crystal clear, Sharma ji? What is your doubt? Yeah, Kirti, Sharma ji, done. Okay, okay. Let's focus on studying. It's fine. Let them be. Don't worry, Shivani. I'm here for you. Don't worry. Now, for myopia, we have this is normal eye, and then this is defected eye, where the image is it is formed in front of the retina. And to correct, we use concave lens. We use concave lens. What are you guys thinking? I use a convex lens. Nobody even told me. Okay, done. Okay, let's move on to the next question. A current through a horizontal power line flows in the east to west direction. Yes, Ramesh ji, correct. Yeah, but I didn't use concave lens, right? Last time I used a convex lens, accidentally. Okay, I also did a silly mistake that you should avoid, okay? Learn from me. A current through a horizontal power line flows in the east to west direction. Now, do you guys remember east to west? Where is north, where is south, where is east, where is west? Anybody has a problem in remembering directions? Let me know. Anybody has a problem in remembering directions? Okay, Ramesh ji, okay. Let me know, I'll tell you. Okay. Great. Okay, great then. If you don't have any problem, great. Now, the current is flowing through a horizontal power line in east to west direction. That means from here to this is the direction of current, right? Now, what is the direction of the magnetic field? Magnetic field direction at a point directly below it and a point directly above it. Directly above it and directly below it. What will be the direction of magnetic field? Now, one thing, let me make you very clear to you. Below the wire, not above the wire. Okay, done. Problem. What happened? Storm gaming. My lens is concave lens. I have myopia. Okay. Done, Priyanshi. Above dot, below cross. Okay, listen to me. First, they probably will tell you, in this question, if you write dot, cross, inward, outwards, north, south, everything will be okay. But they have told you a current through a horizontal power line. That means the power line is placed horizontally on a plane, right? When the power line is placed horizontally, the above will be this. North will be here. Very carefully, see it, listen to me. Like this, north will be here. But if you place it horizontally, the north will go here, behind my hand, right? North, south, east and west. So directly above the wire, we will use right hand thumb rule. That is very easy. This is the direction of current, east to west. Look, this is the direction of current, east to west. From directly below, it is going from north to south. Understood, everyone? Directly below, it is going from north to south. It is going from below, it is going from north to south, and then above simply it will be south to north. This is my no Sharma ji, listen to me very carefully. Not dot, not cross. When north and south is given, then you have to give the answer in north and south as well. Okay, now this is your power line. You placed it horizontally, and this east to west current is going. So this, my thumb will point in the direction. Yes, Kirti, I am explaining. Listen to me very carefully. Whenever you are giving east to west, so you have to answer in north, south, east, west as well. You cannot answer as dot, inwards, outwards. Okay, Shivani, Sharma ji, listen to me. Okay? Now, this is placed horizontally. So, this north is not above. It is behind. The north is behind. So, this is north, this is south, this is east, this is west. So, when the thumb is pointing in this direction, in the direction of current, the curling of fingers below the wire, the curling of fingers go from north to south. Understood, everyone? Let me take a page of paper. Ruko, wait, everyone. Yes. This is this. Now, okay, I wrote the directions wrong. Okay, thank you Ramesh ji for the sadness. Okay, see, everyone, is these directions visible? Similar to these, north, south, east, west, right? Now this, it is a horizontal power line, so it is not placed like this, it is placed like this. Okay, this Joseph, the first part, I'm doing the first part, done. Now listen to me very carefully. This is north, south, west and east, similar to this. Now this is the power line, but it is not placed like this, it is placed horizontally, so it is like this, right? So this north goes backwards, south comes up front. This is north, this is south, this is east, this is west. Now understood, everyone? Now the current is going from east to west, right? The current is going from east to west. So I'll place my thumb like this, and below the wire, below this wire, the current goes from north, it goes from north to south. Understood? Understood, everyone? So below it goes from north to south, and hence below the wire north to south, and above the wire south to north. Done? Above the wire south to north. Everyone understood or not? What help do you want, Storm Gaming? Done? Everyone? Kirti, Arpita. Hi Arpita, how are you? Okay, Sharma ji. When dot and cross is used, see, whenever they are giving first, whenever you see a word horizontal power line, whenever you see a word horizontal, right, and they have given in the question that current goes from north to south or east to west, right, then your answer your answer should also be in the form of directions, right? That means the magnetic field will be north to south or south to north, correct? Now this is the first case. Second case, when they are simply saying that the current is downwards. See, when they would have said that it is from right to left, it is from right to left, right? When they are given that current is from right to left or left to right or downwards or upwards, downwards or upwards, in that case your magnetic field will be either inward, that is cross, or outwards, that is dot. Done? Hi Ma Durga, I remember you. Can you tell me your name again? I forgot. These questions are from pre-boards of Sahodaya as well as Kendriya Vidyalaya, right? I got comments from you guys that you want me to solve those questions, so I got those questions. Yes, Sharma ji, exactly. The kind of question you'll have will decide your answer, right? Yes, correct, Sharma ji. Great. Good afternoon. Kalpana, yes, Kalpana, I remember you. How are you? How is your preparation going? Done? Can we move on to the next question? Oh, we have one more part of this question, that is list two methods of producing magnetic fields. Everybody knows two methods of producing magnetic field will simply be a permanent magnet or a bar magnet or a horseshoe magnet horseshoe magnet, right? And the second is, first is this and second is a current carrying conductor. Second is a current carrying conductor. Done, everyone? Solenoid, yes, that is a current carrying conductor. Okay, Shivani? Bus, English? Your name is Joseph. Okay, I didn't know that. Okay, this is sure questions. Yes, the question from north to south, south to north, those can come very often. Okay. Huh? What is that, Sharmaji? Okay. Okay, let us move on to the next question. Yeah, in current carrying conductor, you will have everything. The wire, the circular loop, the solenoid. Okay? Everything comes under current carrying conductor. Done? Horilal ji? Okay? Okay. Joseph, right? Okay, let's move on to the next. Oh, by using a permanent magnet or by passing electric current through a conductor, a bar magnet or horseshoe magnet produces a magnetic field around it. When electric current flows through a straight wire or coil, a magnetic field is produced around it. This is the way you can write your answer. Okay? Okay, let's move on to the next question. Oof. Next question we have. Okay. I thought, Sharmaji, that I had your question. I read that. I thought I'll put that in the PPT, but I forgot maybe. So let me know your doubt again. Okay, Sharmaji, we'll solve that question. I won't go without solving that question. Done? Okay, Arpita, thank you for the bow. Okay, let's solve this question. Again, this is a long question, but very easy. You just have to use your little bit of brain. Okay? Okay. Let's see, in the given circuit, A, B, C and D. A, B, C and D are 4 lamps connected with a battery of 60 volt. Done. Analyze the circuit to answer the following questions. What are the questions? Let's see the first. What kind of combination are the lamps arranged in? Series or parallel? This is easy. This is easy. Yes, Joseph, I remember. Easy, right? Let me know what kind of combination is this, series or parallel? Series combination or parallel combination? This is parallel. Sudhanshu is saying. Shivani is also saying this is parallel. Okay. Okay, Ritik. I will remember that. Lamps A, B, C and D are arranged in parallel combination. Each lamp has its own individual branch connected directly to the wire. Correct. Parallel. Great. Niharika, Arpita, Shivani, Kalpana. Sorry, I'm really bad with names. If one, yes. Okay. Done. Great. Everyone, this is a parallel combination. So for the first answer, this is a parallel combination. Great. Now the second, explain with reference to your above answer what are the advantages of this combination of lamps. What are the advantages? Okay, we have answer from Sharma ji. Your first point got. What is this? Okay, every lamp get different current according to their rating. Yes, your first part got vanished, Sharma ji. Sorry for that. Okay, yes. Independent operation, yes. Okay, see, I remember Kalpana. If one lamp burns or fails, the other will continue to glow because each has a separate circuit. Constant voltage. Great. So the first, this is simply what are the advantages of parallel combination over series, right? Advantages of parallel combination, right? Don't write like this. I just write it to save time sometimes. Okay, that will not happen. Okay, you don't write like this. First we have individual operation. individual operation. Since these are lamps, we don't want that if one lamp breaks out, or if I switch off one lamp, all other lamps go out too, right? That means this is the advantage of parallel combination, that we can operate all the devices individually and simultaneously. Yes, question is Pookie Sharmaji. Great. Okay, now second is constant voltage. If it gets constant voltage, right, it will, from the power from the mains, it will get constant voltage to operate on the same power, on the same voltage, right? Great. Uniform voltage. Yes, very good. Kirti. Lamp A. Okay, we have answers from Sharma ji. Why the identical resistors have same resistance? Why not same voltage and the current? Okay, Raghav, this is the norm they have said. See, when you, just like in chemistry, you have IUPAC names, right? So you have decided that in the whole world we'll call this name to this compound. Similarly, in physics as well, we see that whenever we have identical resistors, that means resistance is same, because voltage source is external, and because of that voltage source, current will change. So current and voltage can change, but resistance of that bulb, of that resistor will remain same. Okay? Yes, it will not affect the other if one is damaged. Very good, very good. Yes, Sia. Great. Okay, great. Done. Now we have the next, that is explain with proper calculation which lamp grows the brightest. Okay, listen to me very carefully. Third part we have which lamp is brightest. So let me know which lamp is brightest. Which lamp is brightest? How will we solve this? How will we solve this part, that which lamp is brightness? All are getting same voltage. You said all are getting same voltage, right? Yes, Kirti, I saw your answer. It will not affect the other if one is damaged. Okay, Ramesh Joseph is saying lamp B and C. When they have asked you the brightest, you just have to answer one. Brightest means brightest of all, with most brightness, right? Third, lamp C will glow bright because it has more power than the other. Very good, very good. Okay, C. We have to calculate power. Now power has two formulas, V square by R equals to I square into R, and technically the third formula I into R. Oops, I into V, right? Now voltage is same, so we cannot use this formula, and this formula doesn't make sense because we have resistance. So we will use P equals to I square into R. That means P is directly proportional to I square, right? So more the I, more will be the power, more will be the brightness. More the power, more will be the brightness, everyone. Correct? And that means the bulb which has more current. So 3 ampere, 4 ampere, 5 ampere, 3 ampere. So C is the correct answer. Very good. C is the correct answer. Great. Ma'am, I scored only 22 out of 25 in physics, ma'am. Okay. Shobarem. Is that your name? Okay, it's fine. It's fine. Shob, I'll call you Shob, okay? 22 out of 25 is actually great. It's fine. It's in your pre-boards, right? So, do not worry. In boards, in general, we have seen the trend that people get more marks in boards than pre-boards, right? So, do not worry even if you scored 22 out of 25. Just work towards this. Practice more questions, okay? 22 out of 25 is great. Do not worry. Okay. Just keep practicing. Do not lose that confidence and consistency. Okay? Okay, great. Yes. So C is the answer. Find out the total resistance of the circuit. We have to find out the total resistance of the circuit. Let me know the answer of that. This is very easy. Total resistance of the circuit. IV, the total resistance of the circuit is 4 ohm. Okay, we have the answer as 4 ohm. I'm lost in chapter 3, ma'am. Electricity. The chapter electricity, or which chapter? You got 70 out of 80, Kirti. That's great. That's great. Just keep on improving, okay? Keep revising, keep doing more questions. You will definitely get more marks in your boards. If you are getting 70 out of 80, do not worry. Just keep practicing, keep revising. 4. Okay. Okay, let us see. We have 3, 4, 5, 3. We have 4 resistances. 3, 4, 5, 3. These are in parallel, right? These are in parallel combination. So 1 by Rp will be 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Done? So that will be 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 3 again. So what will be the LCM of this? What will be the LCM of this? Yes, the power will be different in this circuit, Shivani, because we have different values of current, right? And power equals to I square R. So if current changes, power changes. Very good, very good. Different power in the circuit. Great. Now the resistance will be, what will you take the LCM of this? See, 5 into 30, 3 is 15, 15 into 4 is 45. So directly take that. We will take 45. Done. And you can just take the LCM. Okay. 3 into what? 3 into 15 will be 45 plus 4 into, what did I do? Not the 45. Yes, 60. Sorry for that. So 3 into 20 plus 15 plus, okay, plus 12 plus 20, right? So if you take 20 plus 20, 40, 40 plus 15, that is 55 plus 12. 55 plus 12 is 67 divided by 60. Did I do something wrong? What is wrong? Okay, you can just solve this, right? You can just solve this. You will take, what will you take the LCM? You took the LCM as 60, right? So I took 60 as well. So 3 into 20 will be 60 plus 4 into 15 will be 60. 5 into 12 will be 60 plus 3 into 20 will be again 60. Done. If resistance of the circuit is doubled without changing the potential difference across it, what will be the effect on the heat produced? Okay, let me read it. If resistance of a conductor is doubled without changing the potential difference, okay, what will be the effect on heat produced per second? See, when you are referring to voltage and resistance, we'll use this formula, V square into T divided by R, right? If resistance is doubled without changing the voltage, that will be 2R, right? So heat produced will be halved. H2, this is H2, H1. So this will be H1 divided by 2. Done? Done. Okay, done, Sandhya? Solved? Okay, what was the answer? What was the question? Find out the total resistance. So we found out the total resistance. What did I do wrong? I don't understand. What did I do wrong, Sharmaji? Let me just see. 1 by 3, 1 by 4, 1 by 5 and 1. Array, sorry. I get it. That's my mistake. That was current. I am sorry for that. I1 equals to 3, I2 equals to 4, I3 equals to 5 and I4 equals to 3. Correct. This is ampere and I took them as resistance. Yes. Great. Okay. Yes. Okay, Joseph. So you can just find the resistances first. The voltage is what? voltage is a 60 volt. Voltage is 60 volt, right? So while using V equals to IR, from there we have to find resistance, right? So R will be V divided by I. So R1 will be what? V60. Voltage will be same because it is a parallel connection. So this is I1, I1 will be 3. So R1 will be 20. Then R2, R2 is 60 divided by 4. That will be 15 ohm. Write down ohm with those, right? Then R3 will be V divided by I3, right? So V is 60, I3 is 5. So R3 will be 12 ohm. And then R4 will be V divided by I4, that will be 60 divided by 3. Again R4 will be 20 ohm. Now you can just put them in the solution, right? Clean the camera. What happened to the camera? Yes, Sharma ji, great. All of you. Very good, very good. Two wires of the same material have equal length and equal resistance at room temperature. If one wire is thick, other is thin. Explain how this is possible. Explain how this is possible. It is possible because the electrician made the wires thick and thin. Their area of cross section is different, right? What is wrong, Joseph? Hi Zoya, how are you? Arey, okay, wrong, I get it, but what is wrong? You have to write it, right? 60 by 3 is 20, 60 by 4 is 15, everything is right. Suraj, hi Suraj. Now you can just put those Rp in this formula, 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Now this will be 1 by 20, 15. Okay, this will be 1 by 20 plus 1 by 15 plus 1 by 12 plus 1 by 20. We'll take LCM as 60, right? So that will be 3 plus 4 plus 5 plus 3. That will be 15 by 60. That is 1 by 4. 1 by Rp. Rp will be 4 ohm. Done. B equals to 12. Hi Diksha, how are you? Now it's correct. Thank you, Sharma ji. B equals to 12. B will be 15, right? 60 divided by 4 will be 15. Yes, 4 ohm. Very good, very good. Okay, let's move on to the last question of today, and then after that we'll do a doubt that Sharma ji gave, right? Sharma ji, you'll have to write that again. Okay, an electric heater is marked 220 volt, 100 volt. Without calculating the current, determine whether its resistance is more or less than that of 20 volt, 60 volt. I cannot read these. Electric heater is marked 20 volt. Okay, without calculating the current, determine whether the resistance is more or less than that of 220 volt, 60 volt bulb, and justify your answer. I guess your question might be a little bit incomplete, Sandhya. Okay, there are two bulbs. Fine. Wait. Okay. You guys read this answer. Until then, we'll solve Sandhya's doubt. Okay? Electric heater is marked as 220 volt and 1000 watt. Right? And without calculating the current, whether its resistance is more or less than a 220 volt and 60 watt bulb. Right? Justify your answer. We have a formula, right, Sandhya? We have a formula of power which is V square by R, where we don't have to calculate current. We don't have to calculate current, right? Directly you can calculate R. R will be V square divided by P. So R will be what? V square is 220 into 220 divided by power is 1000, right? So these two zeros cancel out. 20 into 22, 22 into 22 is what? 484. 484 divided by 10, that will be 48.4 ohm, right? Similarly for this, R equals to V square divided by P, that is 220 into 220 divided by 60 now. So this cancels out, 6, 3 and this is 11. For 3, you can cancel this out. This will be 7.33, right? That will be 73.3 into 11. That is your R. So R of bulb is definitely more than electric heater. Done. Good afternoon, Prince. How are you? Zeba, Zoya, Ibrahim. Hanji, Ibrahim. Several electric bulbs designed. Okay, Sharma ji, let me just click a picture of your question so that it don't vanish. It shouldn't vanish. Okay. See, Sandhya, we have a very basic formula. Power equals to V square by R. You just have to remember that. We have a formula for power, voltage into potential difference into current by using V equals to IR. Right? Can I put I and R in place of V? That is I into R. That is I square R. Now, instead of putting value of V, can I put the value of I? I equals to V by R. So, P equals to V into I. I is V by R. V into V by R. That is V square divided by R. So, we didn't calculate current. We directly calculated resistance from this very important formula. Done? Okay, we have the answers of the question. Yes. Let's read it. Done. Hanji, Zeba. Yes, Zeba. Welcome to the class. Okay, Sharmaji. Next time. Okay? Okay. Rohan was studying the venation of leaves in the garden. He found it difficult to see vein pattern in small leaves. Then the teacher gave him a magnifying glass A. Now he could better see the pattern of leaves. Teacher gave another glass B to see even smaller insect on the leaves. Where should Rohan keep the leaf to get a better enlarged view? Draw a ray diagram to support your answer. Okay. Welcome, Sandhya. Welcome. If you have any doubt, you can ask more. Okay. Rohan should. Hi, Solo Edit. You came back from the hospital. What happened? Okay. Rohan should keep the leaf within focal length of the magnifying glass. Okay. Hi, Prince. And almost it is going to end. Solo Edit. It is our last question. After that, we will be doing one more question for a doubt that Sharma ji had. Okay, Zeba. I will try to do that. Hey, Prince. Okay, Joseph. Joseph, I read your answer. Okay, so first of all, let me know which lens the teacher will be giving to Rohan. Which lens will a teacher will be giving to Rohan? Good morning, Tanishk. How are you? Hi, Sakshi. Welcome to the live session. Good morning. It's good afternoon, although you just woke up now, huh? Magnifying glass is a convex lens. Very good, Joseph. So, Joseph is saying the first answer, magnifying glass is convex lens. magnifying glass is convex lens. Now Joseph, let me know, why did you place the leaf? Why did you place the leaf between the pole, between the optical center and the focal length? Shivani, Joseph, Zeba. Okay, let me know, why did you place the leaf or at a distance less than focal length of the convex lens? It is convex. It will be convex lens or a concave lens? Okay, Preet, thank you so much. Let me know, will it be a convex lens or concave lens? Okay, then how is that? Joseph, if you want to get an enlarged image, how is it a concave lens? Convex lens never gives enlarged image. Kirti. Yes, let me, okay, wait, Kirti, let me complete this question, then you write down the answer, then you write down your doubt, okay? Okay, everyone, this is convex lens because concave lens never produces magnified image. Concave lenses never produce enlarged image. But in magnifying glass, we need enlarged images, right? Done? Yes or no? Okay, yes, Kirti, I'll get back to you. Convex lens, Shivani, great. Why, Prince? Why shouldn't I say? Wait. Okay, so first is done. Draw the ray diagram to support your answer. Now for ray diagram, we will simply make a convex lens, right? And this is my F1 and this is F2, this is 2F1 and this is 2F2, right? Now the object is placed between, see, Rohan wants to see a leaf. Now he doesn't want to see inverted image of leaf, right? He wants to see erect image of leaf. To see erect image of leaf, great. So it will be between optical center and focal length. So the leaf should be placed somewhere here, right? Now one ray goes parallel and it will pass from the focal length, focus. It will pass from the focus and the another goes into the optical center. If we trace it back, it will meet somewhere here and this will be now my leaf, that is enlarged. This is now my leaf and it is enlarged and erect. It is enlarged, that is magnified. That is the purpose of magnification, right? Okay. Hi, I'm great. Okay, between principal focus and optical center of the lens. Okay. Yes, Joseph, it is correct. Between the principal. Yes, great. Okay. Prove that electrons can't present in nucleus. Give answer. That is a chemistry question. You can ask the chemistry ma'am. Okay. Enlarged view using a convex lens. Leaf must be placed between focal length, between lens, optical center. Great. Very good, Joseph. Okay. Next, this first is done. Second, what will happen if we use a glass slab instead of magnifying glass? Which phenomena will take place? Which phenomena will take place if Rohan uses a glass slab instead of a magnifying glass? This is my glass slab. No significant magnification and refraction. Very good, Joseph. If he uses glass slab, now we want to see magnified leaf. Glass slab does not do any magnification, does not do any magnification. So the whole purpose of the experiment goes away, right? It just produces refraction. Produces refraction instead. Refraction instead. Done? Okay. Next we have, if the power of the magnifying glass A and B are in the ratio of 1/3, yes, Captain America, your name suggests that you can do anything. Happy birthday, Zeba. If a glass slab is used instead of a magnifying glass, the leaf will not be significantly magnified. Yes, very good, Joseph. The primary phenomena that takes place is refraction of light as it enters and exits the parallel faces of glass slab, resulting in a slight lateral shift of the image but no change in size. Very good, Joseph. Answer is 3/1. Okay, guys, Sensi. Yes, ma'am. What is yes, ma'am? How are you doing? Okay, everyone is saying 3/1. Okay, great. So what is happening? They have given that the power of B, A ratio power of B is 1/3. Now focal length is inverse of that. This means power of A divided by power of B equals to 1/3. Now we know that power is 1 by focal length, right? That means this is focal length of B divided by focal length of A, right? This remains the same, 1/3. Now f of A ratio f of, if we inverse it, what will it give? F of A divided by f of B equals to 3/1, right? So f of A ratio f of B will be 3/1. Understood, everyone, how to write? What do I have to repeat? Hi, Prakash Yadav. Hi, Sona. I remember your name. Just ignore Zeba. Okay? What do you want me to repeat, Shivani? Done? Okay, solo edits. This one question. Okay, listen very carefully. They are saying that Rohan has to see a leaf. So the teacher gives him a magnifying glass. So what is that magnifying glass? That is my convex lens. Why convex lens and not concave lens? Because we know concave lens always produces a diminished image. But for magnifying we need a enlarged image, right? So for that we use a convex lens. Now obviously Rohan wants to see an erect image of the leaf, not the inverted one. So where the leaf will be placed? That will be placed between focal length and optical center, because that is the only case where virtual and erect images is formed in case of convex lens, right? So this is the diagram. And then they have asked what will happen to use a glass slab. If he used glass slab, there will be no magnification. Glass slab does not produce any magnification. It only produces refraction. So there is no use of using glass slab, right? And they are saying if the power of the magnifying glass A and B are in the ratio of 1/3. So power of A ratio power of B is 1/3. We can write ratio as this: P of A by P of B equals to 1/3. Now see, P of A divided by P of B is 1/3. Now we know that power is inversely proportional to focal length, right? So for P of A it will be 1 by F of A, and for P of B it will be 1 by focal length of B, right? So can I put that here? 1 by F of A divided by 1 by F of B equals to 1/3, right? Now if you solve it, this F of A comes in denominator, F of B comes in numerator. right? So f of b divides by f of a, and this remains the same, 1 by 3. So f of a, if we inverse it, so that means f of a divided by f of b will be 3 by 1. So that will be f of a ratio f of b is given as 3:1. Understood? Understood, Shivani? Hi Rohan, how are you? Okay, Saraswati, Shivani, got this question? Okay, let's move on to the next one. Last we have of this part, the absolute refractive indices of water and glass is 4 by 3 and 3 by 2. Okay, Shivani, great. So water and glass has refractive index 4 by 3 and 3 by 2. Refractive index of glass of water is 4 by 3 and refractive index of glass is 3 by 2, right? 4 by 3, 3 by 2 respectively. If the speed of light in glass is 2 into 10 raised to power 8 meter per second, if speed of light in glass is 2 into 10 raised to power 8 meter per second, we have to find the speed of light in vacuum. We have to find the speed of light in vacuum. So can you find it? Absolute refractive index of water and glass is this. See, this is absolute refractive index of water, not with respect to glass but with respect to vacuum. This also with vacuum. Now if speed of light in glass is given, so can I use this formula? N of glass into vacuum will be refractive index of glass with respect to refractive index of vacuum. That gives the formula of velocity in vacuum divided by velocity in glass, right? Correct? Now I have to find velocity of light in vacuum. In glass it's given. So V of G is given. That is 2 into 10 raised to power 8. V of vacuum I have to find. This whole is also given. N of GV, this, right? That is 3 by 2. So V of vacuum comes out to be what? 3 by 2 into 2 into 10 raised to power 8. This 2 cancels out. Velocity of light in vacuum will be 3 into 10 raised to power 8 meter per second. Done, everyone? Yes, Joseph, I read it. 3 into 10 raised to power 8 meter per second. Very good, very good. Don't spam this much. I couldn't read other comments as well, other charts, right? Okay, Kirti also said 3 into 10 raised to power 8 meter per second. Very good, very good. Great, both of you, great. Okay, now we have a doubt of our very own Sharma ji. Sharma ji, are you here? Let me solve your doubt. Let me see what is the doubt. Sharma ji, if you are here, I'm going to solve your doubt, okay? Okay, Joseph. Fine. Okay, let's move on to the question that Sharma ji has given to us. Sharma ji's question. Doubt. Okay. Great, Pratishtha, everyone. Done? Okay. Now, Sharma ji's doubt was, let me read it out, okay? Several electric bulbs designed to be used on a 220 volt electric supply. So, voltage is given as 220 volt and there are lots of bulbs, okay? Several electric bulbs designed to be used on a 220 volt electric supply line are rated 10 watt. So, power is 10 watt of each bulb. Right? How many lamps? We have to find how many lamps in parallel with each other, how many lamps can be connected in parallel with each other across the two wires of 220 volt? The maximum current is 5 ampere. Can anyone solve this question? Yes, Zeba, what is your doubt? Several electric bulbs designed to be used on a 220 volt electric supply are rated 10 volt. How many bulbs, how many lamps can be connected in parallel? How many lamps can be connected in parallel with each other across the two wires of 220 volt? The maximum current is, we have two wires of 220 volt, two wires of 220 volt. The maximum current is, I maximum is 5 ampere. Can anyone solve this question? I don't know solo edits, you ask him. Let me know if you can solve this question. Everyone. Wire of 24 ohm is bent in the, okay, wait. Hi Vinay Chaudhary. Let me know. Sharma ji is even not here. How will we solve this question? Kirti is saying 3 into 10 is power 8. Okay. Anyone who can solve this question? Come on guys, let me know the answer. Ma'am, please solve it. Yes, Shivani, of course I'll solve it. I was saying if Sharma ji is here, his doubt we are solving, right? The number of lamps that can be connected in parallel is 110. Okay? Okay, let's solve this. See, these resistances are connected across two wires of 220 volt, right? Correct, Joseph, you are correct. Okay, let's see, power is 10 watt, voltage is 220 volt. So, first you have to calculate the total or equivalent. You have to calculate the equivalent resistance of the circuit, right? Equivalent resistance of the circuit. So equivalent resistance of the circuit will be, now we have power and we have voltage. Can I use P equals to V square divided by R and find the resistance? Let's see, this will be V square divided by P. V square divided by P. So R will be, what is V? V is given as 220. V is given as 220 and it's square. So that will be 220 into 220. Power is 10 watt. So this cancels out. R will be 4840 ohm. So the total resistance is 4840 ohm, right? Yes, Zeba. Okay, Ohm's law is just a law. It is when a potential difference, you have a conductor, right? On the two ends of a conductor, if you have a potential difference, that potential difference depends on the, that potential difference is directly proportional or depends on the current flowing through the 2 points of that conductor. Okay? 0.045 ampere. What are you giving the answer to, Pratishtha? If B is the magnetic field at the point K due to current carrying wire P at the current Q, wait, what will be the net? Okay, let me know. Kirti, just wait 1 second. Let me solve this question, okay? Okay, so R is this. Now, just this is the total resistance. You will have N into R, right? this is the total resistance, not N into R. These are in parallel. So that will be N by R. Do you know this formula? This is simply the formula of R in parallel. 1 by R1 plus 1 by R2. If all the resistances are same, if R1 equals to R2, that means 1 by RP equals to 2 by R, right? And that will RP equals to R by 2, right? Just we applied this formula here. We have N resistances in parallel and the total equivalent resistance is 4840. Oops. Equivalent resistance is 4840 ohm and N you have to find, right? N you have to find. Correct, everyone? Oops. Done. Now listen carefully what you have to do, right? Now N total equivalent equals to N by R, right? From here R is what? N divided by 4840, right? Now this is where it gets crazy because we don't have the value of N, we don't have the value of R, right? But we have V equals to IR. That is why current is given. Now I is given as 5 ampere. R is N divided by 4840 and this is 220 volt. From here you can easily find N. That will be N equals to 220 into 4840 divided by 5. Done? He is calling me grandma because he asked my age and I told him that I am 83. Okay, everyone? Doubt is solved? I don't know, Zeba, the answer to that question. Hey, I did some mistake, I guess. Wait. N by R. R equivalent will be R by N, right? R equivalent will be R by N. Okay. Here. R equivalent will be R divided by N. So that will be 4840 divided by N. Right? Now, here again, thoda sa mistake ho gaya. 4840 divided by N. So N will be 4840 into 5 divided by 220. This cancels out. 22 into 22 will be 484. So N will be 22 into 5. That will be 110 bulbs or lamps, whatever was given. Done? Understood, everyone? Done? Okay, great. Done. We're done with this question. Next, now Kirti, what was your what is your doubt? Sharma ji, you can see whenever you come. Okay? Okay. Ma'am, how come you are using these formulas? They are not in our NCRT. What formulas are not there in your NCRT, Shivani? All the formulas are there in the NCRT. I didn't use any formula. Okay, you are saying this one. See, yes. If you see, they will be in your NCRT. What happens? Listen. You have resistances in parallel formula like this, right? 1 by R1 plus 1 by R2 plus 1 by R3, right? And so on. Till 1 by Rn. N resistances are there. N can be anything. 10, 20, 30, right? Now 1 by Rp. So 1 by Rp. If all the resistances are same, that is R1 equals to R2 equals to R3 equals to all the stuff and equals to Rn, right? So can I add all of them? Simply 1 by Rp will be 1 by R plus 1 by R plus 1 by R plus so on 1 by R till n terms. You studied this in math, right? So this is simple. 1 by Rp will simply, this you take the LCM, R 1 plus 1 plus 1 till n times. So n times 1, that will be n, right, by r. So 1 by rp. So rp is r divided by n, right? That is the formula. What was not completed? What was not completed? How many lamps can be connected in parallel? That was what we had to find, right? That was the doubt, that was the question. Yeah, how many lamps can be connected in parallel with each other across the two wires of 220, the maximum current 5 ampere? If B is the magnetic field at a point K due to current carrying wire P, add the current in, if the current in Q wire is reversed, what will be the net magnetic field at, if B is a magnetic field at a point B due to the current carrying wire P? Okay, so these P and Q wires, are these parallel or something? Kirti? Something is missing in your question. If B is the magnetic field at a point K due to the current carrying wire P, at the current in Q wire is reversed. So, yes, it is 110, Joseph. That's what we found. It is 110. Yes, very good. Kirti, let me know your question. If, no, what will be the magnetic field at one game? Ma'am, it is magnetic field chapter. Yes, it is magnetic field chapter, but see, the question is not complete. You are saying if B is the magnetic field, if B is the magnetic field at a point K, right? This is my point K. Due to the current carrying wire P. So there is some wire P, right? At the current in Q wire is reversed. So what is Q wire? Are these parallel? Are these perpendicular to each other? What? That is not clear. Okay, let me tell you, this answer either is incomplete. Don't worry, this answer is incomplete. Okay, so what you are asking is these. I had done these questions. So what you are asking is P and Q. These are two wires and there is a point K. Okay, if the current in the Q wire is reversed, what will be the net magnetic field at K, right? Yes. So see, two cases, the one you are saying can be two cases if this is a P wire and this is a point K, right? See, if the current is going upwards, what will I use? I have to see the direction of magnetic field, right? I have to see the direction of magnetic field. So right hand thumb rule I'll use. So if current is upwards, my thumb will be in upward direction. So it goes in. So at point K, the field will be inwards. At point K, the field will be inwards, right? And if this is the question, so now if the current is reversed, the direction of current is reversed. See, if the direction of current is reversed, thumb goes downwards, and now at point K the field is coming out. So for downwards the field will be coming out. That means the direction of magnetic field will also get reversed. Okay? Yes, Joseph, ask another question. Done? Now, if this is the case, there are two cases. In P and Q, direction of current is same. Direction of current is same. That means current I in this direction, current I in this direction. So what will happen? Thumb in the direction of current, it goes from here, it comes out, it goes in. So at K, it goes inwards, right? Due to P. Due to Q, it is same. But it doesn't go in, it comes out. This is the magnetic field, right? This is the magnetic field, it comes out, right? So due to Q, it comes out. So it cancels. It cancels. That means the magnetic field at K, provided that K is equally distant from P and Q, will be 0. Done? If these are in opposite direction, this is current in P, this is current in Q, and this is the point K. So now current goes in, it goes in. Due to Q, it comes out, but direction is this, so it also goes in. It also goes in. So magnetic field adds. Right, Kirti? Wire of 24 ampere resistance is bent in the form of a circle. What is the effective resistance between the 2 points at the ends of any diameter of the circle? See, okay, we have this wire, right? And it is given 24 ohm resistance is bent in the form of a circle, okay? What is the effective resistance between 2 points at the ends of any? See, if these is the diameter, this is a diameter, right? Then what can you see? Between these 2 points, between A and B, you have now two wires of resistance 12 ohm and 12 ohm, right? Because length is decreased in half. Okay, Kirti, okay. Okay, this is half. The length becomes half, right? So resistance also becomes half. So this is 12, this is 12. But now they are in parallel. They are in parallel. So what is the effective resistance? 1 by 12 plus 1 by 12. Done, Joseph G. This will be, so RP, this will be 1 by 6, 1 by RP. So RP will be 6 ohm. Okay, Joseph? Okay, Kirti. The live started at 11. Dikshika, can I call you Dikshika? Anshika. Okay, let me know your name. Okay, done. Anyone has any other doubt? Anyone has any other doubt? Let me know. Okay, Joseph. Any more doubt you have? Done, everyone? That is it for this live. We solved a sample papers, not sample paper, but pre-boards of Sahodya as well as KV. So from these, almost this level of questions will come in your examination. I have also solved official sample paper of CBSE. You can go watch that as well. And we also solved lots of your doubts. Okay? Okay, no. Okay, great everyone. Done? So we will end this live right now. This is getting over right now, Shivani. Okay? That is it for this guy, for this slide, everyone. For this live. What is happening? Too much physics I am studying for you guys. Okay, that is it for this live. I'll meet you in the next one. Okay, be prepared for your math exams. All the best. Okay, bye everyone. Bye, Kirti.